Hey everybody, welcome to another episode of Daily IoT. Have some spare time before my Caps take on the San Jose Sharks this evening, and so that's why I'm all decked out, no other reason. Today's episode, we're going to kind of do a little bit of a combination of catch up on some projects and update on some projects that we're trying to wrap up and finish so we can move on to our next endeavor. And that is the hockey puck project as well as the texting dryer project. And so it got a little delayed, not Fictiv's fault. UPS had a hard time. I think it was UPS. Yeah, UPS had a hard time getting this thing to me, but it got here. This is our texting dryer case. So let's open it up. I've been dying to open this thing up and see where we're at on it. So for those of you that are new, we've created this little project here, the texting dryer project that you can hook up, hardwire up into my dryer, which I will do once I have it in the case, that when my dryer finishes, it will send me a text message. Has LoSant as the back end to send me that text. And the awesome folks at Agility Design designed this PCB for it, as well as the case that we are about to open here. All the design files will be in the repo. So if you're interested in recreating the project, you will be able to do that. Oh man, okay. Some paperwork. All right. Moment of truth. I sure hope this thing is done right because it's a little expensive when you don't have your own 3D printer. And so if we have to print it again, it could be in trouble. Okay, so I went with the blue color. Look at that, the thing is beautiful. Let's open this thing up and see what we got here. Okay, if you remember, there's two pieces. There is the top piece, which is this right here, and the bottom, which will hold the board just like that. Let's make sure all the standoffs line up perfectly, and they do. So we will screw the texting dryer into here, and then this has little knockout areas for the connections as well as the antenna, which I believe goes just like this. So we're gonna, it's perfect. Okay, so there's a little hole, again on the knockout on the side of the case for the antenna to poke out. We did an episode on antenna performance. You'll see a little card somewhere here that'll link up to that. You get a little bit better performance with a wire antenna, but for space-saving reasons in my dryer, I'm gonna use the spring antenna. It will give us plenty of range to get the signal down here to my office, to the Raspberry Pi, which acts as the gateway, sends a message out to LoSant. LoSant takes care of sending me a text message. And so then there's a little knockout here on the front so that we can make some wire connections to wire it up into our dryer. This is beautiful. It worked out perfect first time. Thank you so much, Agility Design. They did just great work. Excellent work on this. And then on the bottom here, I've got some screws coming. They recommended some self-tapping screws that are really great for 3D printed material that we can just unscrew it shut after we wire everything up, stick this blue box in my dryer, and we will be good to go. I am really excited about that. That turned out, it turned out so good. Amazing. Okay, texting dryer project. We're gonna call this just about done. I wanna mount that up in my dryer and call it finished. Amazing. Next up, we have our texting, I see a texting dryer. I get so into texting. The puck does not text at all. It's the hockey puck stat tracker. It's this idea. It's over here charging, so I can't show it to you, but let's grab a spare puck here. I bored out a puck, put a photon and some other electronics in there, including an e-paper display to show current stats for different players. The player that I chose was Marc-Andre Fleury, who is injured right now. Hopefully we'll be back soon so that we can see some updated stats. But we accomplished all of the goals of our project except for low power techniques. And so we want this thing to be battery powered for an extended period of time. And so I just wanted to run some tests. So I started by taking the code that we have that grabs the stats. Again, this is using a LoSant backend, grabs the stats from LoSant, displays them on the e-paper display, And I just had that doing it in a loop every 5 minutes. That's not realistic and that's not very low powery, but I wanted to have a baseline of how long a 400 milliamp hour battery would last inside the puck. Remember, all this is jammed inside the puck. And so what I found was I also used LowSant to keep track of this so that I didn't have to watch it and see how often it was updating. The stats aren't changing anyway because Fleury's injured. And so what this would do is every time the puck reached out to LowSant to grab updated stats, I would do a little log in a dashboard so that I could just plug it in, let it run until it died, and then go back and look in LowSant to see here's how many updates, check-ins I got, and here's how long the battery lasted. And the results from that, again, just getting the stats and then doing a delay for 5 minutes, not sleeping or anything like that, just delay. So everything's still running, 5 minutes, and then grab them again every 5 minutes. I was able to get a total of 57 check-ins to LowSant to grab stats. And that equated out to about 8 hours of battery life. Now, 8 hours, sort of, asterisk. I got 5 hours of every 5 minute check-ins. And then after that, I think I was dipping right below that brownout voltage because for the next 3 hours, I got a few check-ins here and there. And so for a total, I got 8 hours, but realistically, consistently checking in as it was supposed to every 5 minutes, I got 5 hours of battery life, which I was actually pretty surprised at. That's not too bad for that little battery. And so next up, the test that I'm going to run is using the deep sleep mode of the particle photon. Now, I've been reading the documentation on sleep modes on the photon, and it is pretty confusing, so I think I will also do a very short video, perhaps tomorrow's episode, on the different sleep modes to help you understand them, because when I went to run my second test, things did not work well because I obviously did not understand the documentation on those sleep modes. So in deep sleep mode, the datasheet says we should go down to about 80 microamps of current consumption. And so I'm thinking that this thing could possibly run for days, if not weeks, at a 5 minute interval. And that's our next step towards low power bliss. I don't know what else to call it. This idea that I want this puck to last. I mean, in an ideal world, an entire season on a single battery would be amazing. I think that's going to be a bit of a stretch using a photon, but we're going to see. I will let you know what the deep sleep results are. No deep sleep, 5 hours every 5 minutes. Not great. But again, the ultimate goal here is not to check every 5 minutes. This is just to get a baseline of how long we can go with those frequent updates. And so I will update you on that, on how we do with our deep sleep test with the particle photon. Last up, more packages. I'm really excited about this. This is sort of a sneak peek spoiler of where we're headed on our next project. I've got an itch to do a project that I will talk about in a future episode, but what we have here, if I can get these open. Wow, they weren't messing around with the tape on this. That's what I like. Okay, almost there. Unpackaged and okay, that's everything. And here we are. It's like vacuum packed. This package has come all the way from China, from Hope Microelectronics. And if you've been watching some previous episodes, you will know that Hope is the manufacturer. Sorry, let's get this baby open. That took some doing. Okay. These are in tray format to avoid the layers. Oh, be careful while removing the bands. I got a few more layers to get through to get in here, but what we have here are a whole bunch of RFM 69 chips. I'm talking a whole bunch of them. And that is all I'm gonna say for now, but that's gonna be our next project I will officially introduce in a later episode, but I'm really excited to play more with the RFM 69. The point of all of this, my YouTube channel and the videos that I post is several-fold. But the most important thing that I'm trying to do is document my journey in Internet of Things and learning more about Maker Internet of Things. And that's why I've been doing lots of projects, you know, texting dryer and the hockey puck and the turkey temp tracker project. I've really been hitting projects hard to get more experience in how to interact with different sensors and on different platforms and different backends and things like that. But I also want to dive deep to get, you know, this sort of jack of trades is a, what's the saying? Jack of all trades, master of none. And I don't want to do that. I don't want to just know a little bit about all of these things. I want to dive deep on some of the things. And that's why with LowSant, I've dug a little bit deeper to get to know that platform a lot better. I've really enjoyed that. It's a very powerful platform, and I'm glad I've been able to do several projects with that to see, you know, sort of the breadth and depth of what it can do. And that's what I want to do now with the RFM69. I want to do depth and learn more about it and really get deep on communicating with these. This is a nice little RF module, and so I've had a lot of fun playing with that. And so our next project will involve that. I'm really excited to share that with you, but that's going to do it for today. Like I said, it was just an update on how the different projects are coming along to keep you up to speed on that. Again, I'm going to post all of the design files now that I've verified that the design is good on both the PCB and the case. I will post those up to the GitHub repository, so anybody that would like to take this and recreate it or use it as a base for one of their own projects, you can absolutely do that. Thank you again to Agility Design for the work that they put in on that. And I will also get back to you on our low power techniques on the hockey puck project. Question of the day. Simple one here. What is your favorite platform? So I've been using several different things. I use the Adafruit Trinket, and I'm talking IoT hardware platform. I've used the Trinket, the Photon, the PyCom YPi. What's your favorite Internet of Things hardware platform for making projects? Stick it in the comments down below. Thank you so much for watching. If you've made it this far in the video, I love you. There's some things going on here. You can subscribe. I don't know where it'll be, somewhere around my head here. I would love and appreciate a subscription. That really means a lot to me. And again, thank you so much for watching Daily IoT, the show where together we're learning how to make the Internet of Things one day at a time.